All right, welcome back, everybody. We are now going to discuss the derivative rules. Last time we got the derivative, this time we're going to get derivative rules. To begin, right, we start with, we're going to start with the simplest rule. Consider a function h of x, and it's the sum of two other functions, f and g. What is the derivative of h of x in terms of the derivatives of f of x and g of x? Well, dh dx is equal to, limit dx approaches 0, h of x plus dx minus h of x over dx. So how do I evaluate this? Well, I simply just plug in f and g, right? I plug in what I know h is, and I get f of x plus dx plus g of x plus dx minus g of x minus f of x, right? All I did was I plugged in the definition of h into this formula. Okay, nothing crazy. Divide by dx. Well, what's the next step? Well, we can group our terms, right? So we can group our terms as so. I can group all the f's together over dx, and I can group all the g's together. And you see that the form of the g's and the form of the f's is just the form of the derivative of those functions on their own. So we get our first rule, the sum rule. The derivative of the sum of two functions is the sum of the derivatives. Put precisely, d dx of f plus g equals df dx plus dg dx. So this is the first step of something called linearity, which is actually a very important property of the derivative. To finish up linearity, we need to look at another property. We're going to define h of x equals a times g of x. Why not g? Switch up the letters. Everyone uses f. I bet g is feeling a bit neglected. H of x is a times g of x. A is just some number, okay? A is just some number. So what do? dh dx, limit dx approaching 0. This time I'm just going to plug h in straight away. I'm not going to, waste time. A times g of x plus dx minus a times g of x over dx. But we share an a. There's an a here and there's an a here. So we can just factor the a out. And we're left with dh dx equals a times a limit of g of x plus dx minus g of x over dx. So it's just a dg dx. Right? I'm going a bit fast here, but as I said in the beginning, this whole series is going to be a bit fast. This is the other part of linearity. So if I multiply by a number, the derivative, I can just pull the number out of the derivative. Okay? Well, what about the next rule? To get the next rule, we're going to be a bit fancy, okay? First, I'm going to introduce a new notation for the derivative. This is just a new notation, it doesn't change anything. So df dx, I can equivalently call f prime of x, okay? And this is equal to the limit as dx approaches 0 of f of x plus dx minus f of x over dx. And this f of x plus dx minus f of x, I can just call this the change in f, at a given x, df of x, right? That's a valid thing. And so, for small dx, it's going to be essentially true that f prime of x times dx is df. So the derivative times my small change gives me the change in my function. The rate of change times the change gives... the rate of change times the thing you're taking the rate of change with respect to. So to be concrete, you might say the speed times the time gives you the change in position, right? The rate that you change with respect to the variable times the variable gives the change in the function. That's all this is saying. Okay? Now, we can also say then that consider f of x plus dx, right? Then that's equal to df plus f of x. So that's f of x plus df. But that's just f of x plus f prime of x dx. So we're going to use this fact a lot in our next proof, that f of x plus dx is just the function plus its derivative times dx. Okay? And this is going to let us prove even more things about the derivative, starting off with the product rule. So h of x is equal to f of x times g of x. What is the derivative of this? What is the derivative of this? Who knows, right? Let's find out. Let's find out. So dh dx equals limit dx approaching 0 of f of x plus dx times g of x plus dx minus f of x minus g of x. Okay? This seems hard to deal with, but remember the formula we just derived. Remember this formula. Okay? We can just plug this in to f and g, and we get the limit as dx approaches 0 of what? Of f of x plus f prime of x dx, g of x plus g prime of x dx. Sorry, this shouldn't be minus f. Sorry. Now we take the derivative. So dh dx is limit dx approaching 0 of f of x plus dx, g of x plus dx, minus f of x, g of x, right? Divided by dx. How do we evaluate this, right? This is not the easy algebra we had before. Well, we turn it into easy algebra, right? This is just, this f of x plus dx is just a sum. Same for g of x plus dx. Plugging that in, what do we get? We get the following. We get f of x plus f prime of x dx and g of x plus g prime of x dx minus f of x g of x over dx. And what's the nice thing about this formula? We've put all the dx into algebra, right? So we can take this limit after we do some cancellations. First, we note that f of x and g of x is going to cancel with this, right? Or I should say this line cancels. F of x, g prime of x is going to get its dx canceled. G prime of f prime of x, g of x is going to get this dx canceled. And these two are going to product and only get one dx canceled. So the whole thing, skipping through the tedious algebra, is going to be f prime of x, g of x, plus g prime of x, f of x, plus f prime of x, f prime of x, g prime of x, dx. Right? And I take the limit. Once I take the limit, this goes to 0, and I'm left with the following rule. d dx, so the derivative, I can write it like this, the derivative of f of x times g of x, right? I can write the function here, or I can write it here. Either way, right? Is equal to f prime of x, g of x, plus g prime of x, f of x. Okay? This is called the product rule. It is a very useful rule. Anytime you're multiplying two functions, bam, product rule, done. Now we're going to get, we only have two more rules left, okay? We're going to do one rule, then we're going to do, we only have two more rules left, but before I do these rules, I want to get a general, I want to just try out some of the derivative rules we've already obtained, okay? And see what we can do there, okay? So, well, I don't want to try them out. Sorry. We have two rules left. what I'd like to do first is to derive the derivative of the function f of x equals x to the n, because we're going to use it to illustrate some of the rules that we're going to put into practice later on, okay? So I'm going to use the derivative of this function as an example, and so we need to know the derivative of this function. So what is this? df dx is, once again, our magic formula, x plus dx to the n minus x to the n over dx. Now you'll recall that x plus dx to the n, right, what does that look like? Well, expanding it, you'll get x to the n plus then n times n x to the n minus 1 dx, and everything else will be at least dx squared into, you know, some multiplying something. So these dx squared terms, we know after we divide by dx and take the limit, they're going to go away. So all we're left with is these first two terms. This one cancels with this one. So we're just left with this nx to the n minus 1, who's going to cancel with the dx, to leave us with df dx equals nx to the n minus 1. Okay? And this just comes from, you know, thinking about, like, you know, x plus dx times x plus dx n times, right? N times. Just, you know, you'll get, there's one way you can multiply all the x's, but there's n, you can multiply every x except one, and then a dx. And that's all this is. So with this rule, or with this formula, we're now going to turn to another derivative rule, and then we're going to apply that rule to systems involving polynomials. So I want you to consider our next function, h of x equals f of g of x. Okay. What do we do with this? We say, we write the derivative because once again, derivative rules. What have I been trying to get across to you? When it comes to derivative rules, we just plug in, okay? So we have f of g of x, f of g of, let's try to be very careful here. This is a bit hard to write. F of g of x plus dx. Minus f of g of x. Okay, over dx. How are we going to deal with this? We got the trick last time. Right? We use the expansion. So dh dx is equal to lim dx approaching 0. Let's get some more. Scroll down, get some more space here. Just scroll back up. Here we go. Of f of g of x plus g prime of x dx minus f of g of x. Okay. Now it seems we're a bit stuck, but not quite, okay? If we call g of x equal to u, I use 3 equal signs because I'm defining this as u. Then I can say, well, du equals g prime of x dx. So I can rewrite the f in there as f of u plus du. And then, well, if I do that, then it's clear that this is f of u plus f prime of u du. So putting all that together, we get dh dx equals limit dx approaching 0 of f of u, which is g of x, times, or plus f prime evaluated at u, which is again g of x, times du, which is g prime of x dx minus f of g of x. All divided by dx. So we see these two cancel, this cancels, and we're left with perhaps one of the most important rules, the chain rule, d dx of f of g of x is equal to f prime of g of x times g prime of x. So this notation is a bit confusing. What does this actually mean for taking a derivative, right? Well, let's consider an example. Consider h of x equals, 2x plus 1 to the fifth. Well, then I can say f of x equals x to the fifth. G of x equals 2x plus 1. Then h of x, right, is f of g of x. Okay? So let's take the derivative. H prime of x then is f prime of g of x times g prime of x. Well, what's g prime of x? It's just 2, right? X to the 1, 2x, I have 2 times x to the 1 plus 1 times x to the 0. So x to the 0, we can just apply our rule from earlier, take its derivative, that we get 0 times x to the minus 1, but that's still equal to 0, so we're good. Here, we get 2 times 1 times x to the 0, which is just 2. So this g prime of x is just 2. On the other hand, f prime of x, applying our rule from earlier, our power rule, we get 5x to the fourth. But remember, we're plugging in g of x. So our actual h prime of x is going to be 5 with g of x plugged in, 2x plus 1 to the fourth times 2. So we actually get the following answer. H prime of x is equal to 10 times 2x plus 1 to the fourth. Okay? And that came from the chain rule. So that's how this rule is applied in practice. Now, we're going to do our final rule of the video. And this rule will basically finish up our introduction of rules. And the next video, we will derive everything we possibly can about, whatever else we want. Okay. So our next rule, actually, you know what? We'll do 2 rules. We'll do another application of the chain rule. Consider h of x equals 1 over g of x, right? This is g of x to the minus 1. So if f of x equals x to the minus 1, then h of x is f of g of x. Okay? Now, bam, apply the chain rule. What does the chain rule say? This is minus 1 over x squared, which is minus 1 over g of x squared, times g prime of x, Right? So that's the derivative of 1 over g of x is minus g prime of x over g of x squared. So now what we're going to do is we're going to use this result in another thing. We want to calculate the derivative of a fraction or a division. So f of x divided by g of x. Well, this is just f of x times 1 over g of x, right? So we can apply the product rule. F prime of x times 1 over g of x plus f of x times 1 over g of x prime. But we just calculated that, right? We just calculated that above. So we can plug in to get f prime of x over g of x minus f of x g prime of x over g of x squared. We're just doing the subtraction of 2 fractions now. So we get f g of x, f prime of x, minus f of x, g prime of x, over g of x squared. Sometimes people teach this as a whole different rule, but it's really not, right? You can always find this rule if you know the product rule and the chain rule. Okay? So, and that's what we've just shown. So this is a nice rule. Some people call it the division rule, whatever you want. Now we're going to get to our final rule, and this rule is another weird one. So consider the inverse function of f defined such that f inverse of f of x is equal to x. So whatever f takes x to, f inverse takes it back to give you x. I can take the derivative of both sides of this expression, right? So I'll get d dx of f inverse of f of x equals 1. Chain rule time, right? F inverse of f of x, that's a chain rule. So I would say I could take the derivative of both sides, which we've done, and then we can say apply the chain rule to get f inverse prime of f of x times f prime of x equals 1. So the final statement is f inverse prime of f of x equals 1 over f prime of x. Okay? And this can be used to calculate the derivative of a function's inverse given the derivative of a function. So this is gonna be a useful trick we'll apply later. Okay. With all of that out of the way, this video is now over, and in the next one we will turn to calculating some derivatives, and you're going to get all the classic results, I promise.